Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on adding binary numbers. Let's jump into the problem statement and start solving. It is going to be easy yet difficult problem, so please pay attention. Last time we have solved the majority element problem from Grind 75 list. We'll mark it check and we'll start with add binary. Okay. Given two binary strings a and b, return their sum as a binary string. Okay, we have two strings a 11, b 1, summation 100. Input a 1010, b 1011, output 10101. Okay. Before we start solving, let's understand how binary addition works. Okay. A is equal to 1010, b is equal to, I'll keep it like this, a is equal to 1010, b is equal to 1011. Okay, I have taken it from the example here. Their summation is equal to, so answer would be, we add from the right and right bits. Okay, so 0 plus 1 is 1, so we write 1 here. Then 1 plus 1 is 2. Now binary can only have 0 and 1s, right? So 1 plus 1 is 2. We make it 1 plus 1 2. That would mean 1 here and 1 carry on top. Carry on top here. Okay. Now this carry will be taken in the next position. So 1 plus 0 plus 0. That is 1. So we'll write, sorry, I missed it. I'll correct it once. 1 second. Please ignore it. We'll start over. Okay. 0 plus 1 is 1. Let me just create something. 0 plus 1 is equal to 1. 1 plus 1 is equal to 0 plus carry 1. Okay. 1 plus 1 plus carry 1 is equal to 1 plus carry 1. Okay. Now 0 plus 1 is equal to 1. We'll write 1 here. 1 plus 1 will be 2. So 2 will be reflected as 0 in the summation and 1 in the carry. Now 1 plus 0 will be 1. Now 1 plus 1 again will be 2. 2 is reflected as 0 in the summation and 1 in the carry. 1 in the carry here. And this 1 will be taken down here and we'll get 10101. Okay. Why 1 plus 1 is reflected as 1 carry and 0 down? Because let's say we have two numbers. 1 in binary is represented as 0001, and if I add 1 plus 1, it is equal to 2. So 2 in binary is represented as 0010, right? So two ones will become 1 in the next cycle and 0 in the first cycle. So we add the summation 0, we give the carry 1. Okay, this is how binary addition is done. Let's start solving it for the code. Okay, so in order to solve this problem, what we need to understand is we need to keep track of the strings a and b. Secondly, we have to add the numbers from the right hand side. Plus we have to take care of the summations, which is going to come down, and the carry for the next iteration. These are the few things that we need to take care of. Plus we have to return the answer in string format only, so we'll be using string builder. Let's start solving and we'll go through a dry run. Okay, so first we'll initialize indices I and j to the last positions. Why the last positions? Because we'll start the addition from the last side of strings a and b. So we can say int I is equal to a dot length minus 1 at the last index. Similarly, int j is equal to b dot length minus 1. Okay, now initialize carry and string builder. String builder because string builders are mutable, carry because we need to keep track of it. So we'll say int carry is equal to 0 in the beginning, string builder result is equal to new string builder. Okay, now there are few things we are going to go through both the strings. So we are going to run a loop, we are going to go through both the strings as long as either there is element available in string a, or there is element available in string b, or there is at least one carry, right? So we can say three base conditions for a loop to run would be I'll say call them loop conditions. Okay, would be first I is greater than or equal to 0. So I is started from the last point. If it is greater than equal to 0, that would mean there are more elements left from string a. Similarly, second would be j is greater than or equal to 0. Okay, and third point is there is a carry from previous addition. So both the strings in the end ended 1011 and 1010 as we saw for this case, but there was one carry left, so we have to go through this summation and add it in the front again. So these will be the base conditions for running a loop. We can use the for loop or while loop. Let's go with while one. While I is greater than equal to 0, or j is greater than equal to 0, or carry is greater than 0. Okay, now first we'll get the bit from a. Similarly, we'll fetch the bit from b, we'll add them, we'll calculate the sum, we'll find out what we need to keep at the bottom and what we need to give it to the carry. Okay, so we can say get the binary digit from string a from string a. Okay, we'll check for the bounds as well if I is in bounds, because it can happen that this condition is no longer true, but since this condition was true we came into this loop, so we'll check this condition again. That's why if I is in the bounds. Okay, so we'll say int bit a is equal to I greater than equal to 0, ternary operation, say a dot char at I, and after this we have to reduce I also, so I minus minus. For the loop to run, I is currently pointing at the last element, so after each iteration it has to be reduced, so I minus character 0. So this is to calculate the integer value. Right now they are in the string format, so string 0 minus string 0 will give us the integer value from the ASCII table. Okay, otherwise if this condition is true, we'll get the integer value from here, which will be 0. Otherwise we'll give the value as 0 only by default, because if there is no value, that is also 0 for the integer bits. Int, similarly, we'll use the same comment for everyone. Command C. Okay, string b. So we can write int bit b is equal to j is greater than or equal to 0, ternary operation b dot caret j minus string 0 or 0. Okay, now we'll calculate the sum. Calculate sum. How are we calculating sum here? 0 plus 1 is equal to 1. So we are adding a, we are adding b, and we are adding a carry also. And we are adding a carry also. Now that there is no carry on top of this one, that's why we are not getting it. So we can simply write the sum as int sum is equal to bit a plus bit b plus carry. Okay, so bit a from here we can see is 0, bit b from here is 1, carry by default is 0 as of now. So we get the sum equal to 0 plus 1 plus 0 is equal to 1. Now when we have 1 second, yeah, so when we have 1, we need 1 at the bottom, so as the summation, and 0 in the carry. How will we get 1 in the result? So right now we have a result and we want to put 1 into it, right? So we can simply calculate it from the sum, saying we have to insert it as the least significant bit. Okay, we'll say insert the least significant bit of the sum at the beginning of the result. Since result is a string, we have to insert sum every time in the beginning from this side. Okay, so we can simply say result dot insert. We can add in the end or insert at a certain index. 0 would mean 0th index. And how will we insert? We'll say sum mod 2. Okay, so 1 mod 2 is equal to 1, right? So result will get the value 1, this one. Similarly, we'll calculate carry. Calculate carry for next position. How do we calculate carry? Simple formula, carry is equal to sum divided by 2. Because if you see, if sum is equal to 0, carry will be 0. If sum is equal to 1, carry will be 1. Sorry, carry would still be 0. If sum is equal to 2, then carry would be 1. If sum is 3, then also carry will be 1, right? So when we see 1 plus 1, we give 0, and 1 plus 1 is 2, 2 divided by 2 is 1, we give 1 as carry, right? So right now we'll get the value of carry as 1. We got 0, no, sum was equal to, what was the value of sum? Sum is equal to 1. 1 divided by 2 is 0, so carry will be 0. Result is 1, carry is 0. In next iteration, when we come to I minus minus and j minus minus, so 1 plus this one. So from bit a, we will now get, in second iteration, we'll get bit a as 1, this one, bit b as 1 from here. We'll calculate the sum as bit a plus bit b plus carry, which will be 1 plus 1 plus, last time carry was 0, right? So 0 equals to 2. Result was earlier 1. So let's save result here. Okay, by now result had become string 1. Now we'll say result dot insert at 0th index. So in front of it we'll insert sum, that is 2 mod 2. So what is 2 mod 2? 2 mod 2 is 0. So we'll insert 0 in front of it. Then we'll calculate carry. Carry is equal to sum divided by 2. Sum is equal to 2. 2 divided by 2 is 1. So carry will become 1. Now in the next iteration, I minus minus, I reaches 0, j reaches 0. So we'll have these bits as 0 and 0, right? Sum is equal to bit a plus bit p plus carry. That would mean 0 plus 0 plus carry is 1, 1 is equal to 1. Now again we'll insert at the 0th index in the result, means we'll insert in the front, that is here, sum mod 2. 1 mod 2, what is 1 mod 2? 1 mod 2 is 1. What will be the value of carry? I'll just comment it. 1 mod 2 equal 1. What will the value of carry? Sum divided by 2. Sum is equal to 1. 1 divided by 2 is 0. Carry will be 0. Similarly, we'll keep adding throughout the flow. We'll go through the same procedure again and again, and we'll keep inserting in front, and we will reach the final solution as 1 0 1 0 1. Okay, let's submit and check if it is working fine. The problem is basically easy and hard at the same time. Okay, somewhere we have used something that is not working fine. LENGTH. Okay, one mod 2, where line number 25. Oh, okay, I was just explaining this part. Yeah, okay, let's see. There's one more error. Yeah, sorry. So once we run out of the loop, we need to now return the solution. So we'll say return result dot toString. It was in as string builder. We'll now return it as string. Okay, submit. Okay, beats 55.5% of the users. I did think of other approaches, but none of them was faster than this one. But 55.57, I believe we can improvise it. If any one of you gets with a better algorithm to solve this question, please let me know in the comment section. I would love to go through it. Apparently I could not find a solution better than this one as of now, but please let me know in the comment section. So that is all from today's video, everyone. Thank you very much. Please like, share and subscribe, and for any comments regarding the videos, please comment in the comment section. Thank you, everyone.